Hello, this is Anthony Waroi, Pre-Technical Studies, Grade 8. And in this lesson, we are going to learn about plane scale drawing. So, what is plane scale drawing? First of all, before we learn about plane scale drawing or before we do plane scale drawing, we need to understand what is a plane scale. Okay? Now, a plane scale in definition is a simple measuring tool that is used in engineering and technical drawings to represent measurements, okay, to represent actual measurements in a drawing. Okay, so you can also say they are used to represent measurements in a reduced or an enlarged scale. For example, if I come and draw a hat, so this is a hat, so let me finish something like that. It is very simple for me to convince you that this is a hat because it is a hat. What have I done? What I've done, I've used certain scales. Okay, maybe I'm representing a hat, maybe some that I've seen somewhere that is maybe physically in front of me. So this hat is not, in terms of measurements, in terms of actual measurements, it does not measure 1 centimeter by 4 centimeters by something. No. If it is an actual object, it measures maybe not 100, maybe 300 centimeters or 2 meters, 3 meters in terms of height and length. But I have used a measuring tool which is called a scale or a plane scale to represent that hat somewhere on a piece of paper, okay, when it is reduced in terms of scale. So a plane scale is a simple measuring tool that is used in engineering and technical drawings to represent measurements in a reduced or enlarged scale. So plane scale drawing, okay, is the act of representing measurements in a reduced or an enlarged scale. That is basically what plane scale drawing is. So a plane scale is that measuring tool, okay, which is used to represent measurements in a reduced or enlarged scale. It is a type of a ruler or a scale, of course, that is used to measure distances on a drawing and convert them into real-world measurements. For example, engineers will come up with such a thing. So, of course, they will not be a hat, but for example, if they want to build a hat, maybe using concrete and stones, they'll first draw it, and then when they draw it, they'll use measurements like centimeters and something like that to represent the dimensions of this house. But they'll use a scale somewhere there where they'll say maybe 1 centimeter will represent something like 100 meters. You get the idea. So it is a certain type of ruler or scale that is used to measure distances on a drawing and then convert them into real world measurements. Now, a plane scale is divided into equal parts, where the first part is again subdivided into equal parts. So let me reduce it so that you can see. This is how a plane scale looks like. Okay, and this is what they are going to use to convert the measurements from here to this. But in this scale, in this scope, we are not going to use plane scale to do drawings, but we are going to understand what are plane scale. Okay, how to draw the plane scale itself. That is why it's called plane scale drawing. It is not scale drawing, it is plane scale drawing, where we will be drawing this plane scale. Okay, but in advanced videos, I'll make a video on how to do scale drawing using plane scales. Now, this is how a plane scale looks like. One, we've said it is divided into equal parts. If you look at this part, the first part, the second part, the third part, these parts, okay, they are divided, they are equal. This, and the rest, they are equal. Where again, the first part is divided into equal parts. Now, this is the first part, and again, this first part is subdivided again into equal parts. So that is how basically a plane scale looks like. This can be in meters, this in centimeters. It can also be in meters and meters. It can be in centimeters and decameters or decimeters. Sorry, it can be in any kind of units. Some of the features of a plane scale include this, which we'll talk about. It's called an RF, a representative fraction. RF, representative fraction. RF, representative fraction. This is always written in terms of fractions. So if you find a plane scale, or if you make a plane scale and do a mistake of writing the representative fraction not in a fraction, that is wrong. You're supposed to use a ref, or a representative fraction, which is in form of a fraction. Okay. Now let us continue and learn the features of the plane scale. Now, for example, if you look at this plane scale from this point, you'll notice that it has scale divisions. What are scale divisions? The plane scale has been divided into sections that represent different units of measurements. For example, meters, centimeters, and inches. For example, if you look at this one that is on top, it has scale divisions of feet, and then from this point it has scale division of inches. You cannot have a plane scale that has meters on this side and then it has inches on this side. No, feet work with inches. Okay. That's how we say, like, for example, 1 centimeter is equals to 100 meters, or a certain number of units. But in terms of how these follow these scale divisions or scale dimensions, I don't know how to call them, they should be in the way that they follow each other in terms of conversion. Okay. For example, if you are working with meters, you cannot work with meters and centimeters. No. If you are working with meters, for example, if you come from 0 to 5, of course you pass through 1, 2, 3, 4, 5. Okay. So if you work with meters, you cannot work with centimeters, because centimeters are 0.01 lesser. For example, 1 meter is made up of 100 centimeters. So before you reach to centimeters, maybe what you can do, you can change this to something like decimeters, and then instead of using 1, 2, 3, 4, 5, you can use 10, 20, 30, 40. You get the idea. Okay. For example, we know that 1 feet is made up of certain number of inches. Okay, maybe 10 or something. In short, what I'm saying, these scale divisions must be of units that are following each other in terms of conversion. If you don't get the idea, just know that if you're working with a plane scale, it has scale divisions where you can use units that are following each other in terms of sequence, and the numbers from this side, from the subdivided part to the other parts, are relatable. Okay, but as we learn the features, you'll get to understand what the features of the plane scale are. So plane scale division is what we are talking about, the divided sections, where we have this part where these are equal, and then we have the first part which is then again subdivided into equal parts, like that. Okay, it often includes main division of large units like meters, this one, and then other smaller units on this side, like what you can see, this feet, then inches. Of course, if this is 1 feet, this cannot be 1 feet. This has to be something lesser. So you get the idea. Okay, because we know 12 inches make 1 feet, etc. Now another feature of a plane scale is a scale ratio. For example, the scale ratio is typically marked on the scale. For example, 1:100, which means 1 unit on the scale is equal to 100 units in reality. So about plane scale scales, for example, if I say 1:100, remember 1 and 100 are using the same unit. For example, this means, in most cases, this means 1 centimeter on my drawing. For example, this is my drawing. Now let's say, for example, this is my drawing. It looks like that. It is a square. If this is if from here up to here, this is 1 centimeter, maybe 2 centimeters, maybe 3 centimeters. This means that my 1 centimeters on my drawing will be represented by another 100 centimeters in the actual drawing. For example, this is a piece of land, and someone asks you, what are the dimensions of your piece of land? And then you tell them, my dimensions of my piece of land is around 10,000 by 10,000, something like centimeters. Now they tell you, draw this for me. What you'll do, you need a scale to draw that, because if you, for example, if you draw 100 centimeters, it cannot be able to fit in a piece of paper. You need a scale. So this is exactly what you need. So you'll say, what you've seen me drawing here, is 1 centimeter on my drawing, like for example this 1 centimeter on my drawing will represent 100 centimeters on my land. So this one is represented by 1 centimeter, 2 centimeters, 3 centimeters, 1, 2, 3. So it means in the actual thing it is 300 centimeters. Okay, so you get the idea of how this scale ratio works. So even in a plane scale, it uses a scale ratio. Okay, the ratio helps to convert measurements from the drawing to the actual size. And the scale used, this is the scale used, this is the RF, the representative fraction. 1 over 50. 1 over 50 is the same as 1 is to 150. So yeah, okay, this and this are the same. The representative fraction is always in fraction, but it means that 1 centimeter represents 150 centimeters in the actual drawing. Okay, so then from there you can do the conversion of the centimeters to meters, if for example you are using this. Another feature of a plane scale is it has 2 or more units. This is what we talked about. It has the primary unit, which is the unit from here up to this point, and then it has the primary unit, yes, it is that, and then it has the secondary unit, which is this unit from here up to this point. Okay, the primary unit, the secondary unit. Okay, so you can also call this the primary and the first. They are used interchangeably. So it has 2 units. Another thing, it has a 0 point. If you look at this point, if this is 0, 5, 10, 15, 20, 25, then you don't say from here going this side to this side, this is 0 to 5. No, the 0 point is the middle point where now the scale works from. Okay, and it is located at the interjection or at the junction interjection where the different units meet. For example, this is in meters. Again, it's not a must that it has 2 different units, but if it has, notice that the 0 point is somewhere where the bigger units are going to the right hand side, and then the smaller units are heading to this other side. And let me say why this 0 point is located here. For example, if someone tells you to represent 22 meters, this is 22 meters. Okay, 22 meters. How will you show 22 meters on a plane scale? So let's say this is our plane scale. It has 0 at this point, and then it has 5, 10, 15, 20, 25. So we know that in this scale we can get 22. This is the one that they have written here, and 22 should be somewhere here. But because we don't want to use this part, instead of using this part, what we do, we come to this other part. Then we know for us to get to 22 from 20, so 0, 5, 10, 15, 20, we need to add 2 more meters. So instead of adding here, because we don't have a scale here, what we do, we come and add at this point. So you'll just say from 0, 21, 22. So you'll say that my 22 meters are represented from there up to there, which is 0, 5, 10, 15, 20, and then after 20 we go from this point 21, 22. So that is how you've represented or you've drawn your plane scale representing 22 meters. So the 0 point is always here. You need to be very keen with that. The 0 point is here, it's not at the beginning. Okay, then one last feature is the graduations, and the graduations are the plane scale has graduated marks that allow you to measure distances accurately. These graduations might be in equal divisions, like every millimeter or inch, depending on the scale. So in short, the graduations are these points. For example, at 5 we have the first graduation, the second one, the third, the fourth, the fifth, like that. Okay, so those points are the graduations. Okay, so another bonus feature is the convenient shape of a plane scale. If you look at this plane scale, it looks like a ruler. Okay, that is what convenient shape means. The plane scale is usually a straight, flat ruler shape for easy handling and precise measuring. So if you draw a plane scale that looks like that, you know, it becomes so hard for you to relate with what the actual drawing is. So a plane scale has a convenient shape. It is a flat ruler shaped equipment. It looks like this, and mostly when I say an equipment, it does not, it is something that is drawn on paper. Although there are people who have made rulers that have plain scale, but you cannot be specific with them. Okay, so plain scales are mostly drawn. They are drawn. When you make a drawing, for example, if you do a plan of a house, somewhere down there you'll need to make a plain scale like this to show the dimensions in real life. So those are some of the features of the plain scale. Now let us interpret one plain scale, or maybe two or three. So example 1, you're told on a scale of 1:150, determine the length of line PQ as shown in the figure below, and then you're given this plain scale, and then you're told to determine the length of P to Q. This one is very simple, just as I told you. This is a 0 point, so you'll just say from 0 we get 5, 10, 15. Then from 15 you come and check from the 0. Do you have an extension on the left? Yes, of 1, 2, and then a half. Between 2 and 3 we have a half. So this is going to be 15. Okay, you start from 0, go to the right, and then come back to the left. So 0, 5, 10, 15, and then from 0 you say plus 1, 16, 17 and a half. Okay, so basically this is what this information is telling us. So this line PQ, the distance of line PQ is 15. Okay, you start from 0, you say 0, 5, 10, 15, and then from 0 again, after moving to that side, you now move to this side. So 15, and then 16, or you add 1, 2.5. If you add 15 to 2.5, you'll get 17.5, as I'm showing you here. Therefore, the length of PQ is 15 plus 2.5, which is 17.5. Let us interpret another one. You're told on a scale drawing, on a drawing of scale 1:100. Oh, and by the way, this sometimes they use a scale in this form, but they don't write RF. But if you write RF, you must write it in form of a fraction. But if you don't write RF, it's okay to write it in ratio form. So that is why they've written that in ratio form, which is also one feature of a plain scale. Now let us continue. On a scale drawing of 1:100, the length of a line is shown as shown. So it comes from somewhere here all the way to somewhere here. So you can see this line. Okay. The unit of the scale is decimeters. Determine the length of the line in centimeters. In short, after you find this, you just convert the length of this line to centimeters. So they are saying the unit of scale is decimeters. First of all, we said we start from the 0 point, and this is our 0 point. Okay, so that is our 0 point. Yes, this is our 0 point. So from 0 we get 10, 20, 30, 40, 50, 60, 70, 80, 90. Then from 90 we come again from this point and say this is 92, 94, 96, 98. Okay, because that is where our line is. So 90, then again after we've gone that way, we come again and go this way. So from 0 we get 90, and then 92, 94, 96, 98. So in terms of decimeters, because they've told us the scale is in decimeters, it is 98. And then we are supposed to convert these decimeters to centimeters. Okay, so I did not convert here, but if you want to convert centimeters to decimeters, it is very simple. We say that 1 decimeter is made up of 10. 1 centimeter is made up of 10. 1 decimeter is made up of 10 centimeters. 1 decimeter is made up of 10 centimeters. So if this is in decimeters, remember this was in decimeters. There's somewhere here gone wrong, but if these are in decimeters, to convert the decimeters to centimeters, so here there's a bit of a miscommunication in this. This one was not in centimeters, it was in decimeters. So we are converting to decimeters, and we say 1. So let me write 1 okay, sorry. 1 this is a bit 1 decimeter is equals to 10 centimeters. Okay, 10 centimeters. So if our plane scale, the unit of measurement is decimeters on the plane scale, and you're told to determine the length in centimeters, so the correct thing to do, apart from this, is say if we've gotten that from this point to this point it's 98 decimeters, so you'll say if 1 decimeter is equal to 10 centimeters, what about 98 decimeters? How many centimeters will those be? It will just be 98 multiplied by 10, which is 980 80 centimeters. So with this information, you'll have to forgive me. I had a bit of a challenge with that, but the correct thing to do is that. So you'll say that from the 0 point to that point, that is 90, and then if you head this side, this is 98, so it is in decimeters, and then you convert that to centimeters by doing this. 1 decimeter is equal to 10 centimeters. What about 98 decimeters? You get 980 centimeters. Sorry for that. Now we can do drawing of plane figures to a given scale, and also that is plane scale drawing. For example, you are told using a scale of 1 centimeter to represent 2 meters, or 1:200. Remember, I told you 1:200 means 1 centimeter represents 200 centimeters. So 200 centimeters is the same as 2 meters. So using a scale of 1 centimeter to represent 2 meters, reduce a rectangle measuring 8 by 4 meters. So this is very simple. You just come here and say, if 1 centimeter on paper should represent 2 in real life in terms of meters, this is what is written here. So in real life, 8 meters by 4 meters will be given by 8 meters divided by 2. Why am I dividing by 2? It's because 1 centimeter should represent 2 meters on my drawing. This is my drawing. So 1 centimeter should represent 2 meters of the actual thing, and the actual thing is in 8 meters. So I should take the meters and divide with the 2 meters, not with the 1 centimeter, with the 2 meters, so that I get the scale in centimeters. So it is 8 divided by 2, I get 4 centimeters. That will represent that 4 centimeter will represent the length, or represent the 8 meters, and then 4 divided by 2 centimeters should represent the 4. Again, 4 centimeters will represent the 8 meters, 2 centimeters will represent the 4 meters. So when I reduce this, I'll just say this is 4 by 2. Again, this should be in centimeters, not in meters. It should be in centimeters. So sorry for this again. So now let us continue. Now we've said you've been given a scale of 1 centimeter to represent 2 meters, or that, and then you're told to reduce a rectangle measuring 8 meters by 4 meters. So what you do, you'll say this means that every 1 centimeter on paper, it should represent 2 meters on the ground. So how will you make this? How will you draw this 8 meters on the paper? All you need is this scale of 1 centimeter to represent 2 meters. So what you'll say if 1 centimeter represents 2 meters, what about 8 meters? 8 meters will be represented by taking 8 divided by 2 to get that in centimeters. And in centimeters, it will be 4 centimeters. So the 8 meters will be represented by 4 centimeters. Okay. So you can use that 4 centimeters. And then the 4 meters, you say if 1 centimeter represents 2 meters, what about 4 meters? Okay, it should be 4 divided by 2 meters to give you 2 centimeters. So this is represented by 2 centimeters. Let's say, for example, you have a triangle like this. Then you're told, using a scale of, again, 1 centimeter to represent 2 meters, draw the right angle triangle with a base of 6 meters and a height of 4 meters. Again, if 6 meters, if 1 centimeter represents 2 meters in actual or in real life, how many centimeters will represent 6 meters? It is just 6 meters divided by 2 centimeters, which is 2 meters, sorry, where you get 6 divided by 2 is 3, so it is 3 centimeters. The 4 meters, we'll say if 1 centimeter represents 2 meters, what about the 4 meters? The 4 meters will be represented by 4 divided by 2. 4 meters divided by 2 meters, which is 2 centimeters. Okay? So, in terms of drawing, you'll say that this was 6 centimeters and 4 meters. Height of 4 meters. So, my 4 meters will be represented by 2 centimeters, and that point should be 2 centimeters. Okay, then the height is 6 meters. 6 meters are represent the base is 6 meters. The 6 meters will be represented by 3 centimeters. Okay, so pardon my drawing. So you get the idea. For example, if you have a circle, you're told 1 centimeter represents 2 meters. Use this scale to draw a circle. So you'll just say a circle of radius 5 meters. So you'll just say if 1 centimeter represents 2 meters, what about 5 meters? Sorry, you cross multiply. 1 times 5 divided by 2. 5 divided by 2 is 2.5. So you just draw a radius of 2.5, come up with the circle, and then you can say that is 5 meters, or you can say it is 2.5 centimeters. Okay, and then somewhere down there write 1:200. So you get the idea of how this plane scale or scales work. So that is the end of the lesson. It's been a long lesson, so you can take your time to pause and learn this. Again, listen to the end, and you'll be able to understand that concept. And then the main thing here to understand is how to draw these plane scales. And drawing plane scales is very simple. You determine the 0 point, and then from the 0 point, let me use this one. You determine the 0 point. After determining the 0 point, you draw equal parts and then subdivide them into different units. So thank you. Consider subscribing. Goodbye.